In Lesson 10.1, we are going to identify linear functions by looking at a table, graph, or an equation. Don't forget to pause the video if at any time it is going too fast. The first thing we're going to do is look at a table to determine if it is linear or not. In order to do that, you need to find the rate of change. If it's a constant rate of change, it is linear. Remember, rate of change is the change in the y over the change in the x. So if you look at the first example from your textbook, if you look in the y column, it is decreasing by 15 every time, and the x column, it is increasing by 2. So the rate of change is negative 15 over 2 throughout the entire table. Therefore, it is linear. In example number 2, the change in the y over the change in the x, we have 15 over 3, 33 over 3, and 51 over 3. These are not equal, therefore it is not linear. Here are a couple to try. First thing we want to do is we want to look for the change in the y. From 20 to 16, it went down by 4, and from 0 to 5, it went up by 5. So our first rate of change is negative 4 over 5. Then it went from 16 to 12, which was going down 4, and from 5 to 10, which is going up 5. So the rate of change between those 2 points is negative 4 over 5. And the last two, from 12 to 8, it goes down 4, and from 10 to 15, it goes up 5. So the rate of change between those 2 points is negative 4 over 5. Since the rate of the change is the same between all the points, it is linear. It's a constant rate of change. For the second example, from 0 to 2, it increases by 2. And from 0 to 2 in the x's, it also increases by 2. So the rate of change is 2 over 2. When we move to the next pair of points, from 2 to 4, it increases by 6. Or from 2 to 8, it increases by 6. And from 2 to 4, it increases by 2. So the rate of change is 6 over 2. And then from 8 to 18, it increases by 10. And from 4 to 6, it increases by 2. These are not equivalent, therefore it is not linear. The second thing we're going to do is we're going to look at a graph. This is probably the easiest one. You just have to look at it, and if it's in a straight line, it's linear, and if it's not in a straight line, it's not. This first example here is obviously not linear because it's curved. The next example is also not linear because of the curve. Take a look at the next 3 examples and see if you can identify if it's linear or not. The first one is because it's in a straight line. The second 2 are not because they are curved. Lastly, we are going to look to see if an equation is linear or not. We learned in Chapter 9 that a linear equation can be written in the form y equals mx plus b. So if we look at these equations, if they are in that form or can be written in that form, it is linear. Off to the side, you'll also see a study tip. It says identifying linear equations. Always examine an equation after it has been solved for y to see that the power of x is 1 or 0. Then check to see that x does not appear in the denominator. Basically, you don't want to have any exponents or it's not going to be linear, and you also don't want x in the denominator when you have it solved for y. Let's take a look at the first example. Y equals x plus 4. That equation, exactly how it is, is in slope-intercept form of y equals mx plus b. Therefore, that one is linear. The next example, y equals 6 divided by x, is already solved for y, but it has an x in the denominator. If there's an x in the denominator, it is not linear. Take a minute to look at the last three examples. See if you can identify which of those are linear. Right, the first example is not linear. It's not linear because of that right there. If you have an exponent that's greater than 1 or 0, it is not going to be linear. That's going to give you one of those curvy lines. The next one, y equals 3x. That one is in mx plus b form because y equals 3x plus 0. That's linear. And so the answer for that one is yes. And then the last one, h equals x divided by 5. It is solved for y, but it's not in the form of mx plus b. And it also has, oh, rewind, silly me. Must be Monday. I was mistaken. I was thinking the x was in the denominator, but the x is actually in the numerator. So this one actually is linear. It was a little bit of a trick, and I almost fell for it too. This equation can be written this way. X divided by 5 is the same thing as 1/5 of x. That right there is in slope-intercept form of y equals 1/5 x plus 0. Therefore, it is linear. Don't fall for that trick. Remember, only when the x is in the denominator, like in this example right here, is it not linear. Remember, if you need to go back and re-watch the video or pause it at different points, that's totally okay. You want to be ready to complete some problems when you come to class tomorrow. Thanks, and have a good night.